In this video, we'll discuss softmax and multi-class classification. Before we continue, let's review the argmax function. The argmax function returns the index corresponding to the largest value in a sequence of numbers. Here, the largest value in Z is 100, and the corresponding index is 0. Thus, the argmax function will return 0. In this example, the largest value of Z is 10, and the corresponding index is 7. So the argmax function will return a 7. Logistic regression can be used for two classes, but how about if we wanted to solve the following three-class problem? Consider the following images and their label. We have y equals 0 as cat, y equals 1 for dog. We have y equals 2 for fish. Instead of using one plane to classify the data, we will use one plane for each class. In this case, we have three equations representing three classes, but we can generalize to any number of classes. We can also use the graph to represent equations. In this case, nodes are representing the different components of x. We add nodes for each output z. The edges represent the different learnable parameters with subscripts indicating the dimension. This is the plane where z equals 0. The line is where the decision plane intersects with the plane z equals 0. We can overlay our sample images. We see the lines split the classes. If the input is in the blue region, the value of z0 corresponding to the equation 0 is the largest. This is where the blue plane has a higher value than the other regions. Therefore, anything in this region will be in class 0. If the input is in the red region, the value of z1 corresponding to equation 1 is the largest. Therefore, anything in this region will be in class 1. If the input is in the yellow region, the value of z2 corresponding to equation z is the largest. Therefore, anything in this region will be in class 2. Just a note, the yellow line we see is where the plane is greater than 0. The yellow region is where the yellow plane is larger than the blue and red region. We can now use the planes to classify this unknown point. We calculate the output of the plane and apply the argmax function. The result is class 1. The reason the function is called softmax, since the actual distances, that is, dot products for each input vector with the parameters, is converted to probabilities using the following probability functions. Similar to logistic regression, the process of classification is similar. But we use the output of the probability. We see the result is class 1. Training for softmax is almost identical to logistic regression. Finally, there are other ways to create a multi-class classifier. Sometimes softmax is not the best option for multi-class classification. We will not go into the details, but there are several other methods to convert a two-class classifier to multi-class classifier. They include 1 versus rest, 1 versus 1. These methods are used for support vector machines, which we will discuss in the next section.